Good evening, good morning, good afternoon to all who will be watching this video. This video will be about fire safety, and I, along with my members Benton Nyan and Shatise Dobson, will be talking to you guys about fire safety. A problem statement. Here's 2 important facts about fire that you should know before continuing on with us in the project. 1. Every 24 seconds, a fire department responds to a fire somewhere in the United States. 6.3% of the fires that occur are due to electrical sockets catching on fire. Also, a fire needs 3 elements to ignite: heat, fuel, and an anti-oxidizing agent. And a fire can be prevented if you remove at least one element. This project aims to remove the heat. What is the actual issue we are attempting to resolve? My group is attempting to lessen the amount of electrical fires as much as possible. We chose this project because fire safety and all things fire related has become a huge issue in today's society, and we want to contribute any way we can to lessen the amount of fire related deaths and accidents, not only in the United States but all over the world. Relevant information. Continuing. From 2008 to 2017, the number of fire related deaths have jumped back and forth from 10 million to 11 million, with its record high being 12 million in 2008. The leading specific items most often first ignited in residential buildings are due to electrical fires are electrical wires, cable installation, and structural member or framing. Nearly 54,000 homes are damaged by electrical fires each year in the U.S., and these blazes result in over 500 deaths, 1,400 injuries, and $1.4 billion in property damage. Brief explanation of what we're going to do and how we're going to do it. So, our plan is to set up a fire installation system within the building that will suppress the heat you would typically get from a fire. What I'm saying is the suppression system that we're aiming to put inside of the wall will catch a temperature that is close to the temperature of a fire and diminish it with a CO2 canister before it gets to the point where it could harm others or harm the building itself. The materials we use are 2 thick pieces of large wood and 3 pieces of medium-sized wood. If I had the dimensions present, I would present them to you, but unfortunately I do not have that with me at the moment. We will also use 2 electrical outlets and 2 wires associated with electrical outlets. We also have 36 12-gram CO2 canisters, none of which have been used yet, and we do not intend to use all 36. We also have a circuit with a 50 megavolt battery, a thermocouple type K with an input between 150 and 180 degrees Fahrenheit and an output of 50 megavolts, 4 to 6 screws, and a solenoid with a 12.5 voltage reading, and a structure to hold the canister in place before it gets released to diminish the fire or potential fire. The image to the right of me is what we have had so far before the quarantine started. In the image, you will see the electrical outlet, you will see the wall, the socket, you see the wall placement, you see the wall framing and the placement, and you see the electrical cords that would be connected to the outlet and the inside of the wall once it is set up. As research we have done, we have not found any others attempting to solve the problem in the same direction that we are. And as we all know, there are ways to stop a fire. Sadly, majority of them come with a huge price. We also know the hefty amount we would have to pay in damages gained from a fire. To implement our system, it will cost about $30 or less, because the one thing that has to be replaced after the fire, which is in theory never happened because of our mechanism, is the CO2 canister and the wires. Results if we had more time. If we had more time to test our prototype, we would have used an object that emits heat, possibly a match, and placed it on the electrical socket in order to heat up the wire. As the temperature of the socket rises, the thermocouple will read the appropriate voltage and set up the solenoid, which will puncture the CO2 canister. Once the CO2 canister is punctured, it will let out its gas and decrease the temperature, therefore diminishing the fire before it has even started. All this testing would have been done in a confined room where no one would be subject to injury obtained from the canister. Additionally, we would have been able to create a suitable case for the solenoid, the thermocouple, and the CO2 canister. Thank you for your time.